looking at density and how it starts to interact with our matter. By definition, density is the amount of matter in a given space. And this makes sense. If you've ever heard the term, your cheesecake is dense, that means there's a lot of cheesecake particles in a certain amount of physical space. Sometimes we hear it described as compactness. How close are the particles packed to one another in three-dimensional space? Mathematically, we would need to know two different pieces. We say that density is equal to the mass of our substance, mass being the measure of matter, over the total volume, volume being the amount of space it takes up. It's pretty straightforward when we start to think about it, and oftentimes our density gets compared to water. Water has a kind of special value. We say, so DH2O, so the density of water, is 1 gram per centimeter cubed or gram per milliliter. And this is important because if we want to say how dense something is relative to another, we can do a very simple water test. So here I've got my big tank of water, nothing but water, no tricks here, it's just a tank of water, and its density is 1 gram per milliliter. We have 1 gram worth of matter, of mass, per centimeter cubed of space. So the easiest way to determine if a substance is more or less dense than water is the flow test. Here I've got a little button. I can throw that in my tank and see what happens. Oh, it sinks. It must have a density greater than 1. Its particles are more compact than the water we submerged it in. Another one here, we've got this a big cork stopper. You could probably guess. Less dense, it would have a density less than 1. Piece of styrofoam, you could probably guess. Yeah, also less dense than water. I've got here, this is just a die from a board game. Throw that in my tank, and it sinks to the bottom. What this does mean is we can start to compare our substances relative to water, but there's got to be a way to quantify this. There's a way we can get this value. And so if we wanted to think about this die, or this dice, we could mathematically calculate its density. We would need to know two things. We would need to know its mass. Well, how do we measure mass in chemistry? Oh yeah, we just put it on a balance. So we could take this, put it on a balance. I did this earlier for us. The mass of this particular die comes out to be 20.0 grams. Came out very cleanly, very nice. And so we know its mass. We would also need to know the amount of physical space these particles are occupying. We need to know its volume. Well, what's nice is this is what we call a regular object. We could have clearly defined sides. So if we've got a three-dimensional cube, to find the volume of a cube, it is length times width times height. Good news, this particular cube is 2 centimeters on edge. So we've got a cube that's, sorry if we want volume, make sure I'm still on screen here. Nope, I sure aren't. We've got a volume, find volume, it's length times width times height. I know I have a length of 2 centimeters, I've got a width of 2 centimeters, and a height of 2 centimeters. 2 times 2 is 4, times 2 is 8. I apologize, it did not include my degree of uncertainty. We've got a line for the 2, and so this would be 2.00 technically. 2.00 centimeters. These would all have 3 significant figures. I apologize for my measurement error here. So if we were to multiply all these together, we would end up with 2 times 2 is 4, 8.00. Centimeter times centimeter times centimeter is centimeters cubed for the volume. We could then take our mass divided by our volume, 8.00 centimeters cubed. Let me throw that in real quick. I didn't want to do all of the work off screen for you. So we got 20.0 divided by 8.00 with 3 significant figures. The density for this particular dice comes out to 2.5. Ooh, 3 sig figs, 0. And we've got grams over centimeters cubed. We call this a derived unit. These stick around. Grams per centimeter cubed would be our final density unit for this particular substance. This number is bigger than 1, therefore we know it is more dense than water. We know that when we put it into our tank, it sinks on down to the bottom. Cool. Now, given this information, there's a lot of different types of questions we could ask. We could give you the volume and the density, tell us the mass of the original object, or we could ask what is the volume given this density and this mass. And so kind of thinking about how we can start to describe our particles in three-dimensional space.